dangerous. What would be the ultimate consequences for planet Earth if the magnetic field were to disappear altogether?
5, 4, 3, 2, 1. We have ignition.
The answer has become clear only recently.
And we have liftoff of NASA's Mars Global Surveyor as America begins its journey back to the Red Planet.
In 1996, NASA sent a satellite to Mars.
Mars has been a difficult planet to get to with spacecraft. Even after 16 missions by US and Russia and so on, we still did not know whether Mars had an intrinsic magnetic field or not.
The Martian rocks.
It was this long-standing question which Mario Acuna and his team from NASA hoped finally to settle. What they actually uncovered was considerably more significant.
Nature had big surprises for us, beyond our wildest expectations.
Hidden in the history of Mars lay the connection between magnetism and life.
And here is where we develop our expensive toys, our instruments. This is our lab.
Mario is one of the world's leading experts on extraterrestrial magnetic fields. He has sent instruments to measure them all over the solar system.
This one went to Jupiter, Saturn, and beyond. This is Voyager 1 and 2. This one went to Mercury with Mariner 10. This one went around the orbit in the Sun. This one went to Comet Halley, for example.
To measure magnetic fields, Mario uses a technique which was discovered a century and a half ago.
The simplest way to measure a magnetic field is with a little magnet like we have here that has been mounted in such a way that it can move freely in 3 dimensions. And this magnet, because magnetic field is a force field, will align itself with the Earth magnetic field, in this case, in this direction that we have here, which is actually going into the core at an angle of 70 degrees here and pointing north. So that gives us an idea of the direction of the field. And you can see that, and if I perturb this magnet just slightly, how fast it recovers the original position gives us indication of the strength of the magnetic field. So it's very weak for the Earth, and if I use a strong permanent magnet, then we see that our test magnet moves much faster. So if I make this magnet work against a spring, I get an idea of not only the direction of the field, but also how strong it is.
In the Mars Global Surveyor satellite, the instruments are electronic rather than mechanical, but the principle remains the same. A tiny electromagnet which works against a magnetic spring.
So here's my spring, here's my magnet, and if I pass an electrical current through my spring and measure the disturbance of my magnet, which is inside, then I can transmit back to Earth the information about the strength and the direction of the field we are trying to measure.
As Mars Global Surveyor started to send back data, it soon became clear to Mario and the team that today Mars has no overall magnetic field. But the satellite also detected signs indicating that that had not always been the case.
We found these huge magnetic fields in the crust, and all of a sudden a completely unexpected and unknown planet, in a sense, emerged.
Although there was no magnetism coming from the core of Mars, strangely, large areas of the surface were strongly magnetic. The Martian crust is mainly made of frozen lava, a remnant of the time when Mars was covered with volcanoes. And there is a way volcanic rocks can get magnetized when they form. If molten rock cools in a strong magnetic field, iron-based minerals in it can pick up that magnetism, and the resulting solid rock will itself be magnetic. So, the fact that there was magnetism in the Martian crust proved that when the lava first erupted, Mars must have had a global magnetic field.
And not only that, at an intensity which is 20 to 30 times that of the Earth.
And so that's basically similar to Earth.
Mario's team now knew that Mars had once had a magnetic shield, which it must at some point have lost.
Well, not most of them, but 30 or 40.
They began to wonder whether this might be the solution to one of the great mysteries of the solar system. Scientists suspect that the young Mars was in many ways an Earth-like place, with a thick atmosphere and oceans which may have harbored primitive life. But then, around 4 billion years ago, the planet entered a catastrophic decline. Gradually, the atmosphere and oceans of Mars mysteriously disappeared.
The puzzle was, where did the water go? What process could have caused the loss of water?
Mario realized that two dramatic events in the early history of Mars might lead him to the answer.
We found two very large impact basins in the southern hemisphere of Mars, which are Hellas and Argyre. There was absolutely no magnetization over them.
In these basins, formed when two huge meteorites hit Mars, the rocks were strikingly free of magnetism. And that was odd, because the huge impacts must have melted the crust. And as it cooled again, the rock should have become magnetized by the strong Martian magnetic field. Yet, there was no trace of magnetism in Hellas and Argyre.
Which immediately meant that they were formed after the magnetic field of Mars has ceased to exist. And the estimate is that these impacts took place more than 4 billion years ago.
4 billion years ago is when Mars was beginning to lose its water and atmosphere. Though not all scientists agree with him, Mario is convinced that the timing is not just a coincidence.
If we shut down the magnetic field, then the solar wind has direct access to the atmosphere of Mars. Then we have a process which is equivalent to the erosion in a desert. The wind blows and it blows the sand away. In this case, the sand are atmospheric particles. Slowly but surely, the atmospheric gases, which includes water, are carried away and are lost to Mars.
The loss of its magnetic shield could well have meant death for the red planet. Exposed to the wind of radiation from the sun, over millions of years, its atmosphere was gradually blown away, leaving the sterile world we see today.
If we were to turn off the Earth's magnetic field, the same process would occur. The atmosphere of Earth would be exposed to the erosional effects of the solar wind, and it would be slowly carried away.
The fate of Mars suggests that without the protection of its magnetic shield, the Earth could also become a dead planet. Which makes it all the more disturbing to learn that our own magnetic field is fading so rapidly. Evidence of that decline has come from a surprising source. People have been making pottery for thousands of years. Archaeologists study pots to learn about ancient cultures. But these vessels have another story to tell.
Pottery acts just like a magnetic tape recorder. It records the Earth's magnetic field when the pottery is first made.
An ancient pot is a magnetic time capsule. John Shaw has learned how to extract from it a precise measurement of the strength of the magnetic field as it was in antiquity. Like volcanic rock, clay contains tiny pieces of an iron-based mineral called magnetite.